This case study is for a company that is a global leader in the field of large industrial filters. These filters are similar to the ones you might have to filter water in your kitchen, but are much larger. Most of them are used for reverse osmosis in large water treatment and desalination facilities. This company has been making filters for years and used barcode technology to track each individual serialized filter. Each filter is completely water tested. These actual test results are unique for each individual filter, so it isn't just a simple pass-fail type of test. The barcode process sometimes slowed them down and caused inefficiencies. They could see that they could cut cost and increase efficiency by using RFID technology and enhanced filter tracking. The two pictures on this slide show some examples where RFID could increase their efficiencies. The picture on the left shows filters coming out of a hot oven. It would be difficult and time-consuming to read each of the 16 filter barcodes with a handheld scanner, since the barcodes are placed in the center of the filters. But due to these difficulties in using barcodes, it was not worth the effort, so they lost traceability at this point. But fixed position RFID readers could read all 16 filters automatically at the same time. The picture on the right shows a typical view of the plant floor. The process of making filters is fairly labor intensive and requires a person to manually move the work in progress filters throughout the facility. At any one time, around 5,000 filters are scattered in various stages of WIP around the facility. Twice a year, they are required to stop production and have personnel manually scan each filter barcode in the complete facility for inventory purposes. This means manually separating every filter and making sure the barcode is positioned so it can be read with a handheld scanner. With an embedded RFID tag, the filter serial number could be quickly read without the manual separation and rotation of the filters. They also saw some potential for their end users to use the RFID for their own inventory purposes, since some of the large water treatment facilities would use tens of thousands of these filters. The filters could also include original test data, and the end user would easily be able to compare the current used filter performance to the original manufactured performance of that particular filter. We have already talked about some of the issues the plant had with barcode technology, and you can review them at the top of the slide. So I'll focus now on the benefits that the RFID technology had in increasing their efficiency and reducing their cost. RFID tags can be read from any angle. This was a big efficiency enabler. They could read straight through the filter to an RFID tag on the back side of the filter without worrying about orientation. RFID technology can read multiple tags at the same time. This significantly sped up their twice annual inventory process. And finally, water test data for each filter was saved to the user memory of their RFID tag, so it could be read by plant and warehouse personnel as well as by the end user. Even though two filters have the exact same part number, the variation in their actual performance is important to the end user. Also, RFID tags are not affected by abrasion, ultraviolet light, or other environmental conditions and will last the life of the filter. Shown in the top row of the images are the RFID reader equipment that was used on this project. This includes, from left to right, an RFID label printer, handheld RFID reader, fixed position RFID reader, and corresponding antenna. Shown in the bottom row of pictures are some examples of the custom handheld RFID reader screens that we used to interact with the tracking system. They allow the user to see the information stored in the RFID tags. The new RFID system delivered on all the plant's initial needs for increased efficiency and reduced cost. The biggest savings were in the plant-wide inventory reconciliation. The plant has been able to complete the inventory process in less than half the time of the previous barcode-based inventory system. A process that took from 6 to 24 hours to complete has now been completed in as little as 3 hours. Richard, if you can go to the next slide. After the initial installation of RFID system, additional projects have been implemented to expand the system for further cost savings, such as a robot application had to stop and rotate each filter through 360 degrees in order to allow a barcode reader to scan the serial number of a filter. By replacing the barcode reader with an RFID reader, the plant was able to cut valuable seconds off of the robot execution process. Somehow there were filters that were being lost between the manufacturing facility and the production warehouse. By installing more fixed readers at locations such as dock doors, they were able to track and eliminate these lost filters. And finally, the company is now looking at enabling extra features in the RFID tags to add functionality the end user will see as adding extra value to their filters.